The James Webb Space Telescope, or JWST, is the most powerful telescope ever built. It's a huge step forward in our ability to explore space, doing things that older telescopes could only dream of. It's like a giant time machine, allowing us to see the universe billions of years in the past. By capturing light that has traveled for such a long time, JWST shows us what the universe looked like when it was very young. JWST can see things that are invisible to our eyes. It uses infrared light, which allows it to see galaxies so far away that their light has been traveling towards us for almost the entire age of the universe. This ability opens up exciting new possibilities for understanding how the universe has changed over time. These distant galaxies are incredibly faint and difficult to see. They are so far away that their light is stretched out, making them invisible to our eyes and even to many other telescopes. But JWST is incredibly sensitive. It has a huge mirror and special detectors that can capture even the tiniest amount of light from these ancient galaxies. It can collect the faintest light from these faraway objects, revealing secrets from the early universe. This allows scientists to study how the first galaxies, stars, and planets were formed. This incredible telescope is showing us the universe in a way we've never seen before. It's not just about distant galaxies. JWST is also giving us amazing views of our own solar system, showing us details about planets, moons, and other objects that we couldn't see before. Beyond our solar system, JWST is also helping us study planets around other stars, called exoplanets. By looking at the light from these distant worlds, it can tell if they have atmospheres, and maybe even if they could support life. The information collected by JWST is helping scientists answer some of the biggest questions about the universe. How did the first stars and galaxies form? What is the universe made of? Are we alone in the universe? Building and launching JWST was a huge effort, involving thousands of scientists, engineers, and technicians from all over the world. Their hard work and creativity have given humanity a new way to see the cosmos. As we continue to explore the universe with JWST, we are reminded of how curious we are and how much we want to learn. The discoveries we make today will inspire future generations to continue exploring the vast universe. Imagine a horizon, but instead of being on Earth, it's in space. This is called the cosmological horizon, and it's the edge of the universe that we can see. It's the farthest we can see because light can only travel so fast, and the universe hasn't been around forever. Light from beyond this horizon hasn't had enough time to reach us since the Big Bang, which is when the universe began. It's like trying to see beyond the horizon on Earth. It's impossible. This horizon is the limit of what we can see in the universe. In 2024, JWST made an amazing discovery. It found a galaxy called JADES-GS-z14-0. This galaxy is so far away that its light has been traveling for over 13.4 billion years to reach us. That means this light started its journey when the universe was incredibly young. But here's the confusing part. How can we see a galaxy that seems older than the universe itself? The answer is that the universe is expanding, and this expansion changes everything. The universe is not standing still. It's constantly expanding, getting bigger in all directions. Imagine baking a loaf of raisin bread. As the bread rises, the raisins move further apart. In a similar way, galaxies are moving away from each other as the universe expands. But there's even more to it. It's not just the galaxies moving apart, but the space between them is stretching too. This stretching changes the light that travels through it. Cosmic redshift, stretching light across the universe. As light travels through the expanding universe, it gets stretched out. This happens because the universe has been expanding since the Big Bang. The light from distant galaxies has been traveling for billions of years, and during that time, the space it travels through has been getting bigger. This stretching is called redshift. It's called that because when light is stretched, it looks redder. We can see this redshift in the light from distant galaxies. It's similar to what happens when a siren passes by. The sound of the siren changes as it moves towards or away from us. Just like sound waves, light waves are affected by the movement of galaxies. Redshift is an important tool for astronomers. By studying the redshift of light from distant galaxies, scientists can learn about how fast the universe is expanding and how galaxies are spread out in space. This information helps us understand the universe's structure and how it has changed over time. By measuring the redshift of a galaxy's light, we can figure out how far away it is. The relationship between redshift and distance is a fundamental concept in cosmology, which is the study of the universe. The greater the redshift, the farther away the galaxy and the earlier in the universe's history we are seeing it. This means that by observing galaxies with high redshifts, we are looking back in time, seeing these galaxies as they were billions of years ago. Dark energy, the universe's mysterious accelerator. This is where things get really interesting. Not only is the universe expanding, but it's expanding faster and faster. It's like someone is stepping on the gas pedal of the universe's expansion. This acceleration is caused by a mysterious force called dark energy. We don't know what dark energy is, but it makes up about 70% of the universe's total energy. This mysterious force is pushing everything apart at an increasing speed. A universe in 3 acts: the Big Bang, matter, and dark energy. The universe's expansion has happened in 3 main stages. First, there was the Big Bang, a time when the universe expanded incredibly quickly. Then, matter became the dominant force, which slowed down the expansion. Finally, about 5 billion years ago, dark energy took over, causing the universe to start expanding faster again. We are currently living in this dark, energy-dominated era. Beyond the horizon, JWST's quest to see the unseen. Even though JWST can't see beyond the cosmological horizon, it can still teach us amazing things about the early universe. The cosmological horizon is the limit of what we can see, but JWST's advanced technology allows us to see farther and with more detail than ever before. By studying the most distant galaxies, we can learn about what the universe was like shortly after the Big Bang. These galaxies are like cosmic fossils, preserving information about the universe's early days. JWST is like a time machine, allowing us to look back into the universe's past and uncover the secrets of its earliest moments. It's an incredible tool that is changing our understanding of space. The data collected by JWST will help scientists answer big questions about dark matter, how galaxies form, and how the universe has evolved. With each new discovery, we get closer to understanding the vast universe and our place in it, unraveling the mysteries of the early universe. JWST's observations of the early universe are already making us rethink what we know about cosmology. The discovery of galaxies like JADES-GS-z14-0, so far away and so early in the universe's history, raises big questions about how galaxies were formed. As JWST continues to observe the cosmos, it will undoubtedly find even more surprises, expanding our knowledge and inspiring us to explore the universe's greatest mysteries.